Start math. You will first need your EL. Why do I want to say EL? Your math spiral and your pencil. So go ahead and get that first. Let's go ahead and find our assignment for today. So you will find this under math, my remote learners. Today is Wednesday, so it's lesson 7.9. All right. Today's kind of a fun day because we get to use all of our learning to help us solve real life problems using our fraction concepts. So we're going to do more problem solving so we can solve these in real life. You're going to use that understanding. You're going to use those skills, Josh, that we have to solve these problems. Okay, so listen, and let's start first with just a 3-act task. Go ahead in your spiral. I want you to write down, we did this yesterday, your noticings and your what you wonder. What do you notice? What do you wonder? Okay. And I thought since we're going to do some activities with scissors and paper, this would be a perfect 3-act task for us today. All right. I'll play it more than once. It's called the paper cut. Here you go. Watch carefully, Finn, Cooper. Watch what's happening. Okay, I'm going to play it again. Get your math brains thinking. What do you notice? What do you wonder? Start writing since you've seen it once. I love how Charlie started his sentence. I noticed with a capital letter. Love how Elena started on the left side of the paper at the top. Kids practicing for 4th grade writing. Okay. All right, Gavin, what did you notice? And I'm going to write down your thinking. If you guys didn't write anything down, here's some examples you can write down. Gavin, go ahead and unmute and share. What did you notice? Or what are you wondering?
I wonder why he is cutting it.
I wonder why he is cutting. Thank you for sharing, Gavin. Boy, Gavin, you are like doing amazing today. I'm really proud of you. Ben.
What I wrote down I noticed he cut it into a rectangle.
Ooh, that's definitely using your math brain, Ben. I noticed he cut it into a rectangle. That's something we really need to know to do this today. So Ben, thank you for doing that, for sharing your thinking. Yes, Gabe, what do you wonder or notice? Ooh, I noticed that too. I noticed, this is what Gabe Levine is thinking. I noticed that on the back of the paper, it is colored. Did you say colored? Yeah, okay. All right. Lucas. Excellent. So we have those. So I'm going to keep those. Good. Marin. That's definitely using your math brain. I noticed that there were 6 stripes when he turned the paper over. Thank you, Marin. Great observation. Charlie. Okay, so we did get that. He cut the paper, so we have that. Thank you, Serne. So yours is why is he cutting? So we kind of have, we noticed that he cut it into a rectangle. She's wondering why. Go ahead, Lila Maris.
My notice is that the stripes on the back were symmetrical.
Okay. I notice that the stripes on the back were symmetrical. I can tell you guys are really thinking mathematically today. That makes me so happy. And Elena, Bob?
I noticed that he was cutting a square in the middle of a piece of paper.
Was it a square or a rectangle? Okay, so you agree with Ben. What are you thinking, Sunny?
I wonder how many rectangles did we have to cut with the one piece of paper?
Okay, so Sunny's is a little different. I wonder how many rectangles. You want to finish that for me? How many rectangles what? That he can make with one piece of paper. Thank you for sharing. Okay, if you didn't get to share, keep those wonderings happening. Let's go to our second part here. So which piece, here's going to be your question. I want you to write your answer on in your math spiral. We're looking at area. Do you think the white outside has a greater area or the rectangle on the inside has a greater area? Which piece of paper has a greater area? And then be ready to explain your reasoning. Here, I'm going to go ahead and show it to you again. There it is. Whoa, let's see if I can, yep, I will. Which piece of paper has a greater area, the white outside or the striped inside? So you can just write outside or inside if you want.
Outer in.
That would work as well. All right, stand up if you think the white frame or outside has the greater area. Max thinks so. Okay, so does Evie. They think that that has a greater area. Stand up if you think the striped colored rectangle has a greater area. All right, it looks like at home. Are you standing for that, Ben, for the striped one? Okay. From what I can tell, the majority of us are thinking that it's the striped colored one. The minority says it's the outside. So it'll be very interesting. I'd like to hear Max's reasoning for why you think it would be the white outside.
I think it is the white is because I compared it. So I looked at the line on top. It was smaller,
Okay.
and then I decided to flip it. I just do the top, and it was smaller too.
So visually you kind of compared it.
Yeah.
And you think that it would be smaller, the colored one. Evie, what about you? Why did you think it was the outside would be a greater area than the colored piece?
I just visualed it, and I pictured all the pieces smushed together into one rectangle, and it looked like a bigger.
Oh, good explanation. She said she kind of smushed it together in her mind and it seemed like it would be bigger. So who would be willing, how about Henry? Why did you stand for the colored rectangle, the striped one? Why do you think that one has a greater area?
Why I think has a greater area is because it's not just one square. It's like multiple squares and it's filled in.
Okay. Well, thank you for sharing your reasoning. I appreciate that. All right, so I'm going to give you some information. What do we know about area anyways from our previous units? Josh, what do we know? Area's the inside. What else do we know about calculating area? What are you thinking? Anyone? Sunny?
That if you know the measurements of the side,
Uh-huh.
you can multiply the numbers and you get the entire area.
So she says if you know the side lengths and you multiply them, you can find the area inside of it. Do you remember, Cooper, the equation for that? What do we say? Area equals length times width. So here's some information to help you out. I want you to write this down. So let's see if I can make it a little smaller. Let's pretend these are like inch squares. You can count the side lengths in inches and find the area of the whole piece. If you can't tell, let's count it together. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Whoa, 14. Now that one doesn't count. So 14 by what? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. A 14 by 12. (14 by 12). Problem is, I haven't taught you how to do that. You're going to have to break numbers apart. Do some thinking. So if we know that the whole sheet is a 14 by 12, I'm going to give you some more information. Here's the middle sheet. Ready? We can compare that to the area of the piece that was cut out. So the whole sheet is 14 by 12 area. The smaller rectangle is, do you guys want to count? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 by 1, 2, 3, 4, 5, 6, 7. Is 12 by 7 is just the rectangle that was cut out. How will that information help us, do you think, Sawyer? How can we use that to help us? We know the area of the whole sheet and the inside that was cut out, but we're trying to compare the little strip that was left over to this rectangle. How might we do that? Okay, does anyone, Max Deesberg, what do you think? How come they're giving us that information? How might that help us know the answer? Square inches, okay. Any other ideas? Lila?
So I think that we could add 14 plus 12 and then
You don't want to add, we multiply when we figure out area, right?
but like after we find this area, we can subtract it by this area.
Yes, so if you didn't hear Lila, she said if we can figure out the area of the whole sheet and subtract the area of the rectangle, then we'll know what the outer border is. We'll know the area of that as well. Josh, any ideas? I saw your hand was up. What did you want to share, hon? Well, I want you to tell me how can you, I want to hear your thinking. Okay, so he's going to share and I'm going to do what he's saying. So he knows that the whole sheet is 14 by 12. So he said first he's going to multiply 4 times 12, okay? What'd you get? 48. And then what about this 10? Do you have to do something with that? 10 times 12 would be 120. And then how are you going to know what the total area is? Add them up. 8 plus 0 is 8, 4 plus 2 is 6, and 1 plus nothing. So you're telling me that the area of the whole sheet is 168. Does anyone agree? This is Josh's thinking. Okay, so square units, whether they're inches, I'm pretty sure they're inches, but we'll say units in case I'm wrong. So Josh, so that's the whole sheet is what you think. We still need to know the area of the what?
Smaller rectangle.
The smaller rectangle. How would you figure that out?
12 times 7.
Okay, what's 12 times 7? I haven't taught that. How do you know?
What I know is 7 times 2 is 14.
7 times 2 is 14, and then,
And what I do is I know that it's
but what about that 10? 80, 84. So he's finding the inside rectangle by pulling the numbers apart and adding them together. That's brilliant. All right. So now if we know the small rectangle is 84 square units, and we use Josh's thinking and Lila's thinking, what would the next step be, Sonny? 168 minus, what would that equal? Can you do that? You can do that kind of math, can't you? What's 8 minus 4? 6 minus 8, can we do that? Can we do 16 minus 8? And what does it equal?
8.
So now we're finding that the outside would be. So now let me ask that question. Let's go back. The question again is which has a greater area? The outside? Let's look at it again. What did Lennox say? He didn't stand for either, huh? All right, Lennox, let's see. Okay, so now stand up if you think the outside square has a greater area. Stand up if you think the inside has a greater area. Okay, interesting. Okay, so I have some people that didn't stand at all. Let's see why. Are you ready?
Yeah.
Here we go. They're equal. And if you go back, if we go back to what Josh just walked us through, I don't know if all of you caught it, but he just proved that they were equal. I don't think Josh even caught it. Look, Josh, you said the outside would have 84 square units, yeah? And then down here, you told me that the rectangle had 84 square units. You didn't really notice that they were equal. You did the math though, and we just you proved it. So congratulations between Sunny and Lila and Josh. You guys did it. That was really impressive. Give me a thumbs up if you also did it. You figured that out. That was not third grade math that I've taught you. So you guys deserve some fireworks. I think our brains are now ready for what we're going to do today. Well done, you guys. Well done. I love those 3-act tasks. I think I have one more left for the year. I might have to find a different website for them. Yeah, Graham Fletcher's about done with those. All right, we know our math vocabulary. We are, like I said, this is our last lesson on fractions. Can you believe it, guys? That was really quick. So a fraction's a number that names part of a whole or part of a set. A unit fraction, we talked about this today, Elena, in Think Central. What does it have on the top? What is the numerator of a unit fraction? Hold up your finger. What is it, Elena? 1. Good girl. Numerator's the top number in a fraction that shows the number of equal parts counted. Sometimes we see them shaded. The denominator's the bottom number in a fraction that shows the total number of equal parts in the whole. Equivalent means, microphone answer. Equal. Just like our water around the world is equal? No, it is not distributed equally. That's why you guys are going to know that word so well, because we're talking about that in EL, right? They're not fair shares. Equivalent fractions named the same amount are equal, like 1/2 and 2/4. An equivalence chain has the equal sign to connect those fractions that show the same amount or are equal. All right, you will need today for our thinking 2 pieces of paper, a ruler, and I'm going to start, don't touch those, please. A ruler, a pencil, and scissors. We are going to be making 2 square pieces of paper. I'm going to hand out a rectangle. This is what I want you to be thinking while I pass this out. And most likely at home, you don't have a square piece of paper. Most paper comes like 8.5 by 11. It is a rectangle. How are we going to make our paper into squares? Be thinking. Don't raise your hand yet. Your hand will get tired. I'm going to be passing out rulers and paper to everyone. All right, ready to go? Hey, thank you for your patience. Who thinks they have an idea about how we might turn our rectangles into squares? Jensen, I would love to hear your thinking.
So you fold one corner and like not to the halfway of the rectangle, just so like a quarter.
How would I know that it's going to be the right length though? Don't do it. Don't do it. I'm just listening to thinking. Do not do it. Think about how
And
you
then you
no, that wouldn't be able to just fold it and know it's going to be square. I gave you a tool to use. Think about that tool that I passed out or asked you to get. Serena, nope, we don't fold it in half. If you fold it in half, you're going to have two rectangles. Do not fold it in half. Do not. Don't fold it at all. Do not fold it. Listen, listen. Okay, Serena, what's your thinking? Okay. Hey guys, side conversations. Can't hear Serena. Thank you. Go ahead. So I'm going to show you what she's doing, friends at home. And actually, everyone, she's taking her ruler. And what are you doing with that ruler, Serena? So she's saying we need to make it equal. So how can we make it equal? First, we want to measure. We can't make the short sides longer, can we? Yes or no? No. So let's measure the shorter side. What does it measure? Look, I can just, the width of it. What does that measure? What does it line up to? Max, what does it line up to? Deesburg? 8.5 inches. So if we know a square has all equal sides, what do the other sides have to equal, Robert? Measure it. Where's your ruler? Where's your paper? What are we doing? Get your paper. Get your ruler. Lucas, if we know this side is 8.5 and this side is 8.5 and we need all four sides to be the same, what do we have to do? What do we have to do, Lennox? We have to make what? Haley Booker, listen to Lennox. He's got good thinking to share. Well, we can't do 4.5. We're looking at, we just measured it. He just told us it's 8.5. What do we want the sides to all equal, Sonny? We need all of our sides to be 8.5. So let me show you how to do that. I don't want anyone doing it yet. Just watch. So since we have one side 8.5, turn it horizontally. And you are going to make a line with your pencil where it says 8.5. Put a little line there. Go ahead and go down a little further on your paper. Make another little line where it says 8.5. No, don't worry. Go down again and make another line that says 8.5. When you have your lines, you can line it up. What did I do? I must have got the wrong amount. 8.5. Oops, that one says that one was 8. Make sure your measuring is right. Make sure it's 8.5. And then you can line up your marks. And guess what? Draw a line so you know where you're gonna cut. So it's the same idea, Jensen, but this time I know for sure it's gonna be 8, it's gonna be a square. If it's not, measure your sides, buddy. Make sure they're all equal. If they're not all equal, this whole activity will not work. So everybody check and make sure. Your square will have 8.5, 8.5, 8.5, 8.5. We want all four sides to be 8.5. Make sure you use the ruler to help you. And you want it to, if it's not straight, it's not going to work. We have to do this with both of our papers. Don't cut until you know. So they're not going to cut this So here's what I'm seeing. Some of you think you can eyeball this. You cannot eyeball it. If you eyeball it, this whole activity, nope, Is it gonna work? You gotta turn it horizontally to do your measuring. I'm gonna show you again, but I don't know. Okay, I'm gonna show you again. I want to do it one more time because I see I have to help a lot of you. So some of you didn't quite get it the first time. I want everybody to watch again. Watch carefully. If you watch, I think you'll get it for your second sheet. The paper needs to go horizontally, hot dog style, right? Long ways. You will take your ruler. Max, listen, please. Take it up at the top first. Measure 8.5, put a line. Don't just do that and then line it up and think you can get it straight. That's what happened to a couple people. You have to go down to the middle, line up your ruler, make another little notch or line at 8.5. Come down to the end, line up your ruler, do another line for 8.5. Then what's nice about this is then it will, when you line it up, turn your ruler to make a straight line. You will draw like that and you will see you'll have a square. All four sides will be 8.5 inches. That's what we have to have. We have to have a square. If it's a rectangle, it's not gonna work to do our activities today. All right, once you have that line, you're gonna cut it carefully. And then you can put this scrap aside and you should have 2 square sheets of paper. Okay, I'm getting rid of the other side so it's no longer a rectangle, it's a square. So everybody should have 2 square sheets of paper. I'm gonna give you a couple minutes to get your 2 squares cut out. If you make a mistake, you can probably fix it by taking off an inch or so. If you need help, raise your hand. Okay, you shouldn't have 2 lines though, right? So, All right. Anybody need help or is everybody finished with their squares? So you need to have 2 squares done. And are you ready? You're good enough. That's what you know how to do it?
You just miss a little tiny strip right there, that's just cutting. This, for the purpose, you need that. That's, your line is straight. So this will work. Yeah, for her purposes, this will be fine. Don't worry, one of your edges might not look perfect, but it's.
Talk about a real life use for measuring, right? All right, next part of our activity is on page 369 in your workbook. Go ahead and open up your workbook. We're gonna do a little origami today. So you will have the directions in front of you. This is not only a math lesson, but it is also following directions activity. So that means that we're gonna need to check our whole body for listening, yes? Ears are listening, brain is thinking about what is being said, eyes are looking up here, mouth is quiet, hands and feet are down and still. I think sometimes we like to think we know what Mrs. Aubin's gonna say, and we go ahead, and then we're like, oh darn, I should have listened.
Yep.
So what I would like for you to do is read along with me in your book on page 369, and then we will work together, okay? I will give you some independent time, don't worry, but let's start together. So the art of paper folding began in China. Later, Japan's version of paper folding, called origami, became very popular. Origami sculptures are made from a flat sheet of square paper through folding and sculpting techniques without cuts or glue. So we are going to use our folding techniques to help us and our fractions. So here we go. We're not cutting, Lucas. I'm not sure what's happening. You're on page 369. We're all listening and learning together. Ready? We're ready? Ready? Okay. So the first direction, and you have this in your book, says to fold, and you can, let's take our yellow if we're in person. Fold a square sheet of paper in half diagonally. So, Astria, what do you think that means? If I'm going to fold this diagonally, what does that mean? Watch first, then do.
I think it means that you fold it in half like a taco.
Okay, if I do that, it won't be diagonal. But you're right, I am gonna kind of fold it in half, but Marin, not, oh, like a taco like this or like this? Corner to corner or side to side?
Corner to corner.
Okay, if you go corner to corner, it either way could look like a taco. But corner to corner would be diagonal. So watch, watch, watch. No, 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 no. Don't go ahead. You are going to fold it like this. What shape, Josh Lewis, am I making when I fold it like this? He's telling me that I made a triangle. Can you do that, Josh, for me with your yellow sheet? Thank you. Hold up your triangle when you have it. You have folded it in half diagonally. Or like Astria said, like a taco. All right, now we have to do the math to go with this. If I'm folding it in half diagonally, what part of the square is each rectangle or each triangle? Bird, what do you think? What part of the square is each rectangle? Once you hold it up like Ben is doing, each triangle is what part of the square is what I want to say. What part? It's what fraction? What fraction is each one? Leo.
In half.
Yep, go ahead and write that. 1/2. 1/2. Each one is 1 out of 2 equal parts. Yes? Write it in your workbook. So on your workbook page, it's asking you what part, remember a fraction is a part of a whole. We would say 1/2.
In this case, 1 of 2.
1 of 2, yep. Okay, wait, stop, Haley Booker. Have you written it? No, just number 1. Write your answer. Come on, guys. Follow directions. Here. Look, no more. Now let's take, who can read the second direction? He's just cutting off. Serene, what does the second step ask us?
Fold the paper in half again. What part of the square is each triangle?
All right, so here we go. Keep it folded. We had it in half. Now we have to fold it again. Serene just told us, fold the triangle in half. Again, what shape, Evie, am I making? You should make another triangle. What fraction of the whole would each of those smaller triangles be, Josh? What do you think? What part of the whole square? Now, if we open it up, each section is no longer a half, but here's a fourth, here's a fourth, here's a fourth, here's a fourth. So on your paper, on your workbook, we're going to write what for the number 2? 1/4. 1/4. Notice what's happening to our denominator. What's happening, Max?
It's getting bigger.
The denominator is getting bigger. All right, Max, can you read number 3? What is it asking us to do?
Fold the paper in half again.
Girls and boys. Finn, Haley, Bird, August. Stop talking. Go ahead, try again.
Fold the paper in half again. Open the paper
All right, let's do it. So we folded it in half one time. We folded it in half again. We're gonna fold it in half again. Okay. Now, Henry, what fraction would one of these triangles be when we open it? What fraction would one of these triangles be of the whole? What do you think, Henry?
1/6.
Let's count. Ready? 1, 2, 3, 4, 5, 6, 7, 8. Each one would be 1/8. 1/8. Look at all those unit fractions. So in your workbook, you're gonna write 1/8. And as we keep folding into equal parts, the denominator gets smaller or gets larger as our pieces get smaller. Shh, just listen, just listen. Okay, number 4. Finn, can you read number 4 for us? What's it asking us? Okay, so how do we know the 8 parts have the same area, that they're equal? How do we know that, Finn? Okay, because we folded that, we lined it up, right? We lined it up and folded it in half each time. So we know the parts are equal. And we started with the square. Okay, go ahead and write this in your workbook. You can use your own words. These are kind of Finn's words, but his thinking is spot on. We lined it up and folded it in half each time. So we know that those parts are equal. If they were not equal, would we be able to talk about fractions? No, fractions are equal shares. They're fair shares. All right, then the last thing we get to do. Now we are going to fold 4 triangles to the center as shown on the right. What part of the square is each triangle? And explain how you know. All right, so let's go back. I'll demonstrate. Here you go. And a hush fell over the crowd. All right, here we go. We're going to fold it back the way it was. We first folded it in half again, in half again. Right? Then it said, okay, that's where we ended. Now it says to fold, but I think we're going to have to open it up. Rich, please stop talking to me. No, this is still the same. Now it says to fold 4 triangles to the center as shown. So the center is like, if you want to put a big dot here, you could take your corner, fold that one in. You're going to fold all your corners in. And guess what you're going to make? What shape is that going to make? A square. Well, we had a triangle before. So looking at these triangles, look. What would each one of these triangles be? What fraction? What fraction, Charlie? Well, let's count. Well, it's not going to be 4. It's going to have a 1 in the numerator because each one is 1 out of what? Count them. 1, 2, 3, 4, 5, 6, 7, 8. So each one of these triangles is 1, 8, because we know that we have 8 equal parts. So each one is 1, 8. So there are 4 triangles of equal area covering 4 more triangles of equal area underneath. Pretty crazy. All right, guys, get your green. Put that one to the side. Now get your green square. We're going to go to the next page, 370. The next page is 370. We're going to follow the directions pin. Okay, I'm going to ask August first. I'm going to ask you to let me do my job. Can you do that? That means you need to stop the pen. All right, here's what we're going to do with this one. A little different. You are going to first fold it in half. Now be careful. Don't do it yet. It does not say diagonally, does it? So we have to read the directions carefully. It says to fold a square sheet of paper in half 3 times. Okay? I'm going to demonstrate that. Fold it in half 1 time. And that's not on the diagonal. We already did the diagonal. There's 1. Fold it again. 2. And then we have to fold it again. 3. What shape did I make, Haley Booker? I made a rectangle. So you should fold it in half 3 times. Once you do that, it should look like this. That's 1. Do it again. Nope, the other way. That way. I don't think it's going to matter. They just have to fold it in half 3 times, not diagonally.
I'm just trying to, I missed that
Yep.
part, and that's helping second.
Okay, I see Evie's already thinking. Once you do that, when you open it, Evie, what did you notice? What did you notice, August? What do you see? What do you see when you open it? 8 what? You see 8 rectangles. Are they the same? Yes, they're the same. So listen to what you're going to do. You are going to choose 2 different colors, any colors you want. You're going to color every other rectangle or triangle 1 color and color the other rectangles or triangles the second color. I will show you what I mean. You need 2 different colors. So you're going to open it up and then think of it like a quilt. I'm going to pick pink and brown. Thanks. So when I say every other rectangle, watch. It does not have to be fancy, August. Every other one. So I did that quick, right? I'm going to leave a spot for my second color, brown. You can start Then I have to skip it, right? So it's every other. Watch carefully. When you get to the second one, you're skipping one each time. That's what every other means. It's like skip counting.
Color. Are you color?
All right, now, and is it perfect? No. We're trying to learn about fractions, so don't panic if it's not perfect. I'm kind of just sketching it in here, just scratch. August, I should see you coloring. I'm not sure what you're doing. Can you beat Mrs. Aubin? Haley did. Yeah, Haley still did. Well, don't make it fancy. We're being efficient. Mathematicians are efficient. All right. I'm going to give you 1 minute to do this. About 1 minute to do it. Scribble it in. Scribble it in. It's not going to be fancy. It's not an art project. Just scribble it in. Robert, you can't use that one. You can use that one. You can grab a different one right here. All right.
See how they're diagonal to each other? Not this one and this one being the same. This one, this one, this one, this one. That's why she said every other. There's a diagonal
Okay.
going here.
Now I want you to answer the question. Once you have that done, let's see what we're going to do here that deals with fractions.
What can you do?
Write 3 equivalent fractions for the part of the square that is colored the same color. So let's think about that. What fraction, let's look. What fraction of our rectangle, and if I look at mine, mine is pink, right? You pick whichever color you have. What fraction of that rectangle is pink? Raise your hand if you can tell me, writer. Lennox, what do you think? Is only 1 out of 4 pink? Let's count them. 1, 2, 3, 4. So I have 4/8 are pink. Is that it? Or is there an equivalent fraction for that? How much of that rectangle is pink? Josh? No, there's 8 parts. 4/8. We got 4/8. Also, 1 what? No. If I were to look at fourths, so I hear a lot of people talking about fourths. How many fourths, if I get rid of 4 of them, Lennox, how many of those fourths are pink? Now count them. 1, 2. So 4/8 would equal 2/4. And how many, if you think about this, how many colors did I use? So wouldn't 1/2 also be equivalent? Yeah. So I have 4/8 that are pink, 2/4 that are pink, or 1/2. They mean the same thing. Or what word do we say? They're equivalent. Okay, my last thought for the day. If you were to fold the square 4 times instead of 3. Here, come on, mathematicians, you've got this, Robert. I know you do. If I were to, we folded this 3 times and we got 8 equal parts. What would I get if I folded it 4 times? Henrik, what do you think? How many rectangles would I have if I folded it 4 times? Predict it. He says 10. What do you think, Max? 12. What do you think? 12. What do you think, Josh? 10? Think about it. There's 8. I'm going to fold it in half again. Serne. 16. Fold it in half again and then open it up and count them. See if Serne, Henrik, Josh, or Max is right. Who got it right? Serne, congratulations. How did you know? Oh, Elena, can I have whole body? Yeah, you just made your teacher's day. She said I did 8 times 2, right? Because you had 8. If we were going to fold it in half again, that means you're going to get double, right? And 8 plus 8 is 16. All right, kiddos, that was a lot of hands-on activity for today. How are you feeling, thermometer, on applying your knowledge to real life situations with paper folding, origami? Good job. You can choose to keep these or you can recycle them. That's up to you. Remote learners, you do have lesson 7.9. It should be really short and simple. All right, guys, I hope you have a wonderful rest of your day, and I will see you tomorrow.
Want to see how good I am at origami? I can make